All right, this is a new unit, and what we're doing in this unit is we're graphing, and we're going to graph a lot of different ways, graphing parabolas. So the key here is when you see the word parabola, you know that that's a shape that's going to look like a U, and it's going to either be up or it's going to be down. The other thing that's important when you see a parabola is that you know that this has to be a quadratic. And we just finished a unit on solving quadratics, but remember, quadratic in standard form is ax squared plus bx plus c. So what makes it a quadratic is this x squared part. We don't need a middle term and we don't need a constant, but we do have to have an x squared, okay? So the first thing that we're going to do, it says here, graph on your calculator using a standard window. So from our calculators, what you're going to do is you're going to go up here to y equals, and we're going to do x squared. So we use this x, not the var's x, but we use this x, and then we're going to square it with this square button right here. So just a standard x squared. And when we graph it in a standard window, you're going to hit zoom, which is right here, zoom, and then 6. And that gives us a standard 10 by 10. So negative 10 to positive 10, and then negative 10 to positive 10. So that's what we call a standard window. Now, when we graph this, I'm going to go ahead and graph it here. What we see is that we have this point at 0, 0, and this is by 5s, but we would have a point here at 1, 1. We would have a point here that would look like this. So here is my standard parabola, and this is our parent function. So if we think about a standard quadratic or a standard parabola, this would be it. So x squared, it's here at the origin, and we have this point here at 1, 1, and negative 1, 1, okay? So now let's do a little investigating and see what happens when we switch things up. So now I'm going to go back here, and I'm going to go to y equals, and it's still x squared, but this time I'm going to add a plus 2 on the end. So that's this second question right here. And I'm going to just hit graph because I've already got a standard window set. And now you see what happens is now this parabola starts up by 2 on the y-axis. So I'm going to go up by 2, so right about here. And then again, it's 1 over, and so my parabola looks like this. Now, the takeaway on this, and we're talking about more about this in a few minutes, is if you've got anything added on the outside, this means you're going to go up or down. So we're going to shift our parabola up or down. Okay, so see the difference between these two. That's super important. Okay, so now we're going to add a middle term when we do this. So I have x squared, and then minus 4x plus 4. That's my next one. Okay, so what happens on this guy is you'll see that it's shifted over, and it's going to go through this point. So we have this point that goes right here at 2, and it's going to go 1, 2, 3, 4, so up here at 4. Now, because a quadratic is symmetric, whatever happens on this side is going to happen on this side. So these 2 points are always going to be the same. Okay. All right, so I'm going to talk a little bit about these next two real quick, 4 and 5. So what we see on 4 is we're going to change this coefficient, our a term here. So now I have 0.25 x squared, and it's going to be minus x, so I can delete the 4, and then it's going to be minus 3. So go ahead and graph that one. Now I'm going to do this one just a tad bit different. What I'm going to do is I'm going to put my standard quadratic right here. So this blue graph right here, which would be my x squared. And now I'm going to graph my new graph. And my new graph, I see that it's going to look a lot more like this. Now, here's what's important. What's important is this guy, and we're going to come back to that in just a second, okay? So let's do number 5. And what I'm going to do is I'm going to graph my standard parabola here. And this is my x squared graph. And now I'm going to go in and I'm going to graph this one. So I'm going to have 3x squared plus 4x minus 1. okay? And what we see on this is going to look more like that. Okay, so here's a takeaway on this, and we're going to talk about more about this in a minute. So this is a fraction. This is less than 1, so the a value is less than 1. When the a value is less than 1, my graph gets really wide. This value is a whole number bigger than 1, so if a is bigger than 1, right, so a is 3, it's bigger than 1, then my graph gets very narrow. So sometimes we call this a stretch, and sometimes we call this a shrink, okay? But the width of our parabola is dependent on this a term, okay? All right, last one on the calculator, and then we're going to do some of these by hand. So this last one is negative, and that's a negative, not a minus, x squared. And when I graph that, I see that I'm still at 0, 0, and I still have a point here at 1, 1, but now my graph goes down. So this negative term right here means that the parabola opens down. Now this doesn't have a coefficient, but if it was -3 or -1/2, it would still open down. This negative tells us that it always opens down. So we can tell a lot from the graphs and what the graphs are going to look like just based on the equation. And that's what we're going to focus on, is what do these graphs look like if I can't put it in the calculator, okay? So just to kind of summarize, so the graph of any quadratic equation, so the equation part here is going to be y equals x squared, and remember we can add on to it, but this is our parent function, will look like the shape below. So it can look like this, it can look like this, it can be super skinny like this, it can be super wide like this, and even it can be wide going down. It doesn't matter. It is called a parabola, and it has to look like a U, not a V. A V is going to be something else. So it has to look like a U, not a V. All right? Okay, so when we talk about this, sometimes it's going to be easier for us to graph this if we're in this form called vertex form. And vertex tells us where the bottom of our graph is or where the top of the graph is. So this would be my vertex. You could also look at this as a minimum or a maximum on your graph, all right? So my parent function of a quadratic is y equals x squared. That's my parent function. But in vertex form, my parent function now becomes a x minus h squared plus k. So super important. You've got to know this, okay? I'm going to break it out a little bit so you know what all of these parts mean, okay? So this a value here tells us if we open up or down, and it tells us the width. So like a minute ago, we know that if it's a is greater than 1, then it's going to be skinny. And if a is less than 1, we know it's going to be wide. Okay? This h value tells us anything that happens on the horizontal. So it tells us if we go left or if we go right. And the k value, this value that's on the outside, tells us anything that happens vertically. So if we go up or if we go down. Now we've already seen this k value on the very second one that we graphed, right? So this would be my k value. And if this is my k value, I see that the whole thing moved up because it's positive 2. All right? So, and that's what this next question says. What happens if there is a number added or subtracted at the end? So I'm going to graph these all on the same graph. So I'm going to do my parent function first. So I have this point at 0, 0, and I have this point at 1, 1. And actually, I could even go in here and say 1, 2, 3, 4. I would have this point here at 4, 4. And how do I know that? Because if x is 2, 1, 2, if x is 2, and I square it, I get this value of 4. So this pencil line right here is my parent function, my x squared. All right, now I'm going to do this one where I have a +2. So +2 means I'm going to go up by 2 units. So I'm going to go up by 2 units. So this is my new starting point. And if I go over, I'm going to go up 1. And if I went over again, I would go up 4. So it would be 1, 2, 3, 4. Clear up here, off my paper. Okay, so this graph is going to look like that. And then this last one down here, this guy, this is -2, so this means I'm going to go down by 2. So I start at my 0, 0, I go down by 2, I have my 1 point right here, and so this graph is going to look like that. So the width of the graph, there's no movement in the left or right. All we did when we added a number on the end is we went up or we went down. Okay, so what happens if there's a number on the inside? Now, on the inside, if we look up here in our vertex form, this is what we say on the inside. So it's inside the parentheses. All right, so let me start with my parent function. So here's my parent function. Now, with this one, it's on the inside. Now, this is tricky. If I was going to solve an equation, let me step back for a second. If we had an equation, we solved it, let's say we had these two factors, x plus 2 and x minus 4. And I asked you if we're going to solve it, so it equals 0, what is the solution to this? Well, the solution here is x equals -2 and x equals +4. Okay, so because this is on the inside, this is opposite of what we might think, right? We might think, okay, +2, we're going to go to the right, but I want you to think about this scenario. So if we set this equal to 0, what really happens here is we're going to go left by 2 because this would be a -2, right? Think about this, x plus 2, when we solve it, we get a -2. So with this one, x plus 2, it's going to be left by 2. So I'm going to move left by 2. So that's my new vertex. And I'm going to go up 1 point, and this graph is going to look like this. All right. So this next one, it's the same concept. If I had the factor x minus 2 and I solve this, I would get x equals 2, which means we're going to go to the right by 2. So think of this, just opposite sign of whatever you have on the inside. So I go right by 2, that's my new vertex, those are my points, and it looks like this. So super huge takeaways. So if there's a number added on the outside, then we're going to go up or down. If there's a number on the inside of my parentheses, this is going to tell me that I'm going to go left or right. Okay, now we've talked about this already, but, but what happens when a number is multiplied in the front? So, parent function here. Now, we are going to treat this, kind of like a slope. It's not a slope because a slope would be consistent. So if I had a slope of a line, it would be consistent points all the way across. But we're going to treat this first value here like a slope in terms of what's going to happen. So there's no value on the inside, there's no value on the outside. So here's what I mean by that. If I write this in vertex form, there's no value here that's going to shift left or right, or there's no value here that's going to shift up or down. So the only thing that's going to change is the width of this parabola. So I'm still going to start at 0, 0. But this next point, instead of going up 1 like we did here, so this is an implied 1x squared, that's where this pencil point comes from. Now I'm going to go up 3. So I go over 1 and I go up 3. 1, 2, 3. And what we see is this becomes skinny. So we say that this graph that I have here is it's a skinny, so we say that this is a shrink. The width of my graph got smaller, so it shrunk. All right, so we're going to use the same concept on this. I'm going to start here at 0, 0. But now this says that I'm only going to go up by 1/3. So it's not really a slope. It is not up 1 over 3. This is just up by 1/3. So if I look at my graph and I go over 1 and I'm going to go up 1/3, it's going to be right about in here. It's not going to be all the way up to 1. So now when I graph this, this becomes super wide. So we talked about this on the previous page. If this value here that we have is a fraction, it's wide. If it's a whole number bigger than 1, it's skinny or it's narrow, right? Okay, last example here, and this is what happens if it's negative. So again, I'm going to do my parent function. And this time, I've got two things going on. So I have a negative, and this means that it's going to point down. And I have this 3, which means that I'm going to have a change in my slope. And remember, it's not really slope, but that's what we're going to say with this first starting value. So I have my parent function starts here at 0, 0, because I have nothing on the inside. And I'm going to go down 3, first point over 1, 2, 3. So I'm going to have a point here, and I'm going to have a point here. So what we see is that it's more narrow than my parent graph, and it's going to shape down. All right, so just a little summary here of what we had for everything. Hold on, I'm trying to find, I have it. Okay, so this value here, this is going to be a shift up if it's positive, or down if it's negative. This is going to be a shift right if it's negative, or left if it's positive. Remember, it's opposite of what we think. And this is going to be a change in our starting, I'm going to just say slope, even though it's not slope. All right, so our starting value. And this is going to affect if we open up, down, and the width. Is it going to be wide or is it going to be narrow? All right, so now let's practice this a little bit. So these are all graphs that we are not going to put in our calculator, okay? So let me talk through these, and then we're going to practice a little bit. So this value here tells me that I'm going to go left by 2. And this value here tells me I'm going to go down by 3. So remember, on the inside, we're dealing with left or right, so it's opposite of what we think. And this value, because it's negative, means I'm going to go down. So from here, I'm going to go left by 2, 1, 2, and I'm going to go down by 3, 1, 2, 3. Now this is my starting point. This point is what we call the vertex. Now the vertex happens, this is my x value, and this is my y value. So remember, it's opposite, so this value becomes -2, -3. And we can look at the graph right away and we know where our vertex is. So again, the vertex is either the minimum or the maximum. And then because there's no value of a here, I know that I'm just going to go up 1 on both sides. So this graph will look like that. All right, now there's nothing on the inside here. So there's nothing on the inside. There's no left or right shift. No left or right shift, but I am going to go up by 2. So my vertex here is going to be 0, 2. Nothing here, so it's 0, but up by 2. So 0, up by 2. Now I look at what happens. Well, there's no number here, so it's going to be by 1, but it's going to open down. So I have a point here and here. Okay, next one, I'm going to look at my vertex. So this tells me that I'm going to go right by 2, and this tells me I'm going to go up by 1. So my vertex happens here at 2, 1. 2 because I'm going to the right, and then up because of this. So I go over here 2 and go up 1. Nothing's happening here, so I know that that value here is just 1. Okay, I'm going to keep going on these because I think you're going to get a lot of practice on your homework just so that you can kind of see how this goes. So here, I'm going to go left by 1 and up by 2. So left by 1 means -1, up by 2 is +2. So left by 1, up by 2. So this is my starting point. Okay, up here I have a negative, but there's no number, so that means I'm just going to go down by 1 in both cases. Oops, that was kind of a bad one, sorry. Okay, this one looks a little bit different. It looks a little different because I don't have parentheses. So again, I have no horizontal change because there's no value that's inside my parentheses. But this tells me I'm going to go down by 3. So my vertex here is 0, -3. So I'm not shifting to the left or right, but I am going down. So 0, -3, 1, 2, 3. And then this value tells me that my first point to the left and right is going to go up by 2. So what I see is that this guy is a lot more narrow. Okay, go ahead. Let me do one more. Let me do 7 down here, and then I'm going to pause the video, and I want you to try some of these. So my vertex here, this tells me I'm going to go right by 2 and down by 1. So right by 2 is positive, down is -1. So this is going to start at 2, -1. Okay, now this tells me 2 things. This tells me that I'm going to go down and that I'm going to start at 1/2. So if I go to my vertex, I'm going to go down, so my numbers are going to be down here. So I know my parabola is going to open down, but I'm only going to go down by 1/2. I'm not going to go down by 1. So this point here is going to be at 1/2, and this point here is going to be at 1/2. So 1/2 the distance, and what we see is that this one is wider, which is what we wanted. Okay, you stop the video and you do 6, 8, and 9, and then come back and check. All right. So this one was pretty simple. Should look like this. I don't know why I drew one arrow longer than the other, but it should be down at 2. This one's going to be shifted to the left and down 2, and then our first point is up by 4. So remember, I go over 1 and go up 4. 1, 2, 3, 4, and that's where this point is. So it should be narrow. And then with this one, there's no horizontal change because there's nothing inside the parentheses. So I'm going to start up by 2, and then I'm going to go up by 1/4. So it's going to be wider. All right. Now what we're going to do is we're going to take everything that we just did and we are going to create the equations of the line instead of drawing the line. So this is where our formula is going to come in. So I'm going to write our formula up here. So y equals a x plus or minus h squared plus or minus k. Because remember, we can go left or right, and we could go up or down. So this formula right here is our vertex formula. And remember, the vertex is this point right here. So this is my vertex. And the vertex is really hk. So I look at this value of h, and I look at this value of k, and I'm able to find the vertex. So if I look at this point, my vertex here is going to be 2, 0. Right? I go over 2, but I don't go up or down. So this is my vertex. And if I look, my first point is over 1, up 1. So this means I know that my a value has to be 1 because this is just a standard parabola. So if I go down here, I would have y equals, my a value is 1. I'm going to write that this time, even though we won't do this in the long term. And then I'm going to have h and 2 squared. And this time, I'm going to put plus 0. So this is my h value, and this is my k value, right? And it doesn't matter because this is 0. It doesn't matter if I say plus 0 or minus 0. That doesn't matter. What I'm going to try to figure out here is what sign goes in here. And if you remember, it's opposite of what we think. So because we went to the right, we have a -2. So here's my A, here's my H, and here's my K, and this is how it all fits together. Now, if I was going to write this in like truly condensed form, like how you would write it on a quiz or a test or even on your homework, I would say y equals k minus 2 squared. So no A and no K. So this is really what we're looking for, but right now, if you want to write all of those parts out to make sure you've got them all, then that's good. Okay, so here's my vertex. So I go over 2, so it would be -2 because it's in the negative x direction, and then I'm going to go down 1, 2, 3. All right, so I have to see if I have an A value here that's different. So I go over 1 and up 1. So this tells me my A value is equal to 1. So I have 1, x, -2, I'm going to come back to that, -3. This is always what we think. So if this is -3, this is -3. Now this is opposite of what we think, so it's going to be +2. All right, so with this one, here's my starting point. So my starting point is going to be 0, 2. This is my vertex. So 0, 2. Now, if you look at this graph, if I go over here to one value over, I'm going to go 1, 2, 3. So this value is 3 away. So my A value here would be 3, but my parabola opens down, so my A value here is -3. So when I write this out, I would have -3, this is my A value, and then I'm going to say x plus 0 squared plus 2. Remember, when it's positive, we just put that on the end. Now let me rewrite this in my condensed form without the 0, and I would have -3 x squared plus 2. Let me go down here and do number 6, and then I want you to try a couple of them. So here's my vertex. There's no dots on this, so they're a little bit harder. So my vertex on this guy is going to be 1, 2, 3, 1, 2, 3, 4. So 3, -4. And now I have to look at the first point outside of, to the right and left. So if I go over 1, my first point happens here. So I go over 1, I go up 2. So my A value here is a +2. So I'm going to have 2x minus 3, opposite of what we think, squared, -4. Okay, I'm going to pause the video, and you go and do 4 and 5, and then check your answers. Okay, here's what we have. So this value here is 1/2, so we need to make sure we have this one. And if I look at 6, here's what I have on 6. Now, what you'll notice, oh, sorry, 5. I said 6 on number 5. What you'll notice here, it opens down, so you need to make sure you have your negative. And I didn't put +0 on the end. So as we get into more and more practice, it's not moving up or down, so we don't even want to put that +0. So if you put that on there, go ahead and erase that off. It should look like this. Okay, that's it.